Okay. Ready? Notes, let's go fast here. An open-topped box must have a square base and a total surface area of 3,600 centimeters squared. What is the largest possible volume for such a box? Okay. Again, this is something that we have done in the past using completing the square and graphing, but today we're going to solve it using derivatives. Now, let's try and really work through this as a class. I don't want to really lead anything here, but where should we, got a box drawn for you, so you don't even have to draw a box. Where should we go next? Okay. Yeah. So both kind of coincide. Label it. So what can we label on here? It must be a square base. Yeah, if we're going to do that though, so well, what's a formula for the? We got to find the largest possible volume. So what's our volume formula that we should be using? V equals. Okay, so we do have a square base. Okay, and you guys want to call that H, or you can call it Y, whatever you want, or S, S, Y, whatever. But therefore, with those letters, what is the volume of this box? X squared times H. So we just got to maximize that. Easy. Now, we could take, let's kind of, I don't know if you guys are chess players, right? But whenever you play chess, you always got to be thinking 3 moves ahead. Let's just think 1 move ahead. If I did the derivative on this, what would be bad for me? What's not good here? What's, I'd have the derivative of H, which can't do. Is the derivative of X okay? Doesn't it cancel? Is that what you're... yeah, technically they're both bad. H probably easier to get rid of because you start getting rid of X, you got to square it, right? So we got a plan. We want to get rid of H. So you do have to think a couple moves ahead and go, yeah, both those I can't have 3 variables. I got to get rid of 1. H seems to be easier. It's not squared. Let's get rid of it. How am I going to get rid of H? I need another formula. That H and X are related to each other. Surface area. Okay? Now looking just at this, how am I going to find my surface area? X squared. Is there 2 of them? Why not? Good. Okay. So I got this done. Good. Because there are 4 of these, right? 1, 2, 3, 4. Your 4 sides. X times X is the base. Okay. No, that's good. Well, let's work through these together, because if I just go and put them down, everybody's just going to copy and go, I have no idea what's going on, right? We got to go slow, and we got to do this together. Okay, so that's good. Anything I know in this surface area formula? I do know the surface area. Okay, so I'll put 3,600 equals X squared plus 4XH. Now remember, if I want to get rid of H, I better get it by itself. Okay? So the thing that I see to do that is to take out an X. Is that going to do it for me? Okay, no, it's not going to do that for me, is it? Yeah, minus an x squared is equal 4xh. Okay, so yeah, like, I know sometimes when you take notes, you're like, how on earth did he know to do that, right? Well, so we're going to work through, like, I'm glad let's take out an x or 4x. No, that's not going to help me, right? So you try things, and the more you try things, you get better at it, and you're like, yeah, I'm not taking out a 4x. Didn't work for the last 5, so it wouldn't work for this one. I'll subtract the x. Now what should I do? Then divide by 4x, right? So now I have this formula to go into there. So now volume equals x squared times 3600 minus x squared all over 4x. Okay, let's try and simplify this. What can I do? Okay, I can do that, right? What else? Now, what are we going to do with this after we simplify it? Take the derivative. So I want you to be thinking taking the derivative. What's the divide by 4? Why? That's number 1. And number 2, what's going to be going on that other side after I take the derivative? Is 0. See, when you do enough of these, you start thinking, hey, when I put 0, so if we multiplied both sides by 4, and you may not see that done. You may look, they're going to keep the 1/4 on there. They're going to be, yeah, low, high, high, low, all that stuff, all that work. And you're going to think maybe that's the only way. But I know when I take the derivative of that dv over dx, it's going to be 0, 0 times 4. So that's going to make my life easier. Right now, you're thinking, it's all good, but now I have to do the product rule, don't I? How could I avoid the product rule? Get the x in. So this is 3600x minus x cubed. So I know students are like, well, sometimes you take it out, sometimes you put it in. Like, how do you know what to do? Every time I do a different question, it's because if you think 3 moves ahead, you go, I got to take the derivative of this thing, I'm going to put it in. I'm going to bring that 4 to the other side. It will make my life easier. Now, this is a really nice question to do a derivative on. So we would have 4 times dv over dx. Right? It's all going to be relative to x or respect to x. This will be 3600 minus 3x squared. So here I did the derivative. Here I'm going to find the max. So I'm going to make it equal 0. Now, yesterday you guys had a good question that how do you know if it's a max? How do you know if it's a min? And I said, oh, they're going to be pretty nice to you. But there is a way to always know. You see how this is a negative 3x squared? A negative 3x squared does go like this, right? So you can always check it that way, right? And if it was a positive 3x squared, I bet you they're looking for a min. Okay, so let's go 4 times 0 is 0 equals 3600 minus 3x squared. We can bring the 3x squared to the other side. Divide by 3. Take the square root. Okay, this is the same thing as 100 times 12, right? So this would be 10 root 12, and root 12 is 4 times 3, 4 comes out. So this would be 20 root 3, which is 34.64. Okay, so I found the dimensions of the base. I just want to go back. It says, what is the largest possible volume? Okay, so I can't even put it into my XY formula. I got to actually find the entire volume. Which volume formula should I use? Probably this one, right? With the x's canceled. So V equals, it was x, which is 20 root 3, times 3600 minus 20 root 3 squared all over 4. And if you put that in, you'll get 20,784.6 centimeters cubed. So therefore, the largest possible volume is 20,784.6 centimeters cubed. Okay, so you can see the redundancy that's being built in. We have to find the formula that we want to maximize, then we want to try to get rid of a variable. We differentiate, set it to 0, find it, put it back into original formula. Okay? So they do follow the same sequence all the time. It's just, I think, sometimes getting the two formulas. Okay, so this is a pretty high-level question. You've got a right circular cylinder, okay, well, which is a circular prism, and has to be designed to fit inside a sphere that is 6 meters in diameter, so that each of the corners touches the circular edge of the sphere, aka cylinder is inscribed in the sphere. Find the exact dimensions of the cylinder with maximum volume. Okay. Want to label something? Can we label anything? Okay, radius is 3. Now, even that is like hard. Like, what do you go like that? Okay, that's all good, right? But there's actually one where it helps us, and that's if you go to the corner. Oops. And again, if you're going, oh, I never thought of that. Well, now you would. So what is that distance? 3 meters. Now we want to maximize that cylinder. So what is our formula? Area of the base times height. Right? Area of the base is, so volume equals, let's just do this main formula, area of the base times height. Volume equals pi r squared times height. So we want to maximize that formula. Remember, pi is not a variable. So we only have 3 variables. We need to either get rid of r or get rid of h. Okay, this is h. This would be r. Can I label anything else? How? Okay, I have an almost triangle, but you need two things to find R. It would hard to be it would be hard to find that angle. I don't know how big my R is to find that angle. I do know I can label that blue side. Yeah, 1/2 h. Or h over 2. So I have a way of relating R and h now. Therefore, I can get rid of one of them. Okay, now I got rid of, actually you'll see, let's just put everything in and you'll see why I chose the one I did. We got 3 squared should equal R squared plus h over 2 squared. Now we can make this h equals, or we can make it r equals, right? Yes. That is what I chose to do, but I want to kind of to see that. Do you see how this is an r squared? So I can leave that r squared equals, right? So, but if you actually would have put the square root in there, you'd square r, and you would get it anyway, too, right? But again, if I recommend it, most people, I would have never seen that, right? But as you do more of these, you start to want to think a couple steps ahead. And if you were to solve for h here, it's not going to be fun. But if you wanted to get for r equals, it's not so bad. Or in this case, r squared equals is really nice. Okay, so I'm just going to do this quick. I just brought in my squared. Okay, now if we went 3 squared minus h squared over 4, that would equal r squared, right? Or h over y, whatever you want to put. Okay, so now this can replace all of that. So volume equals pi times 3 squared minus h squared over 4, all times h. Okay, so we could bring pi into both of these and h into both of these. So volume equals, that would be 9 pi h, 3 squared is 9, minus pi h cubed over 4. Okay, now we're ready to take the derivative, but we can do some creative things here to make the derivative easier. Multiply everybody by 4, so that would be 4v equals 36 pi h minus h cubed by h cubed. Okay? There's one more thing you could do to make your life easier. I would divide everything by pi, because that's going to put that here, which still is a constant, right? And that gets to go away. But if you didn't see it, you're still going to get the right answer. But it does make your life... I like, when I get to that derivative, the simplest one is the best, 36h minus h cubed. And that's a pretty good derivative on the right side. Very easy. Did I miss something? Okay. Derivative. So this would be 4 pi times dv over dh equals 36 minus 3h squared. So that's my derivative. Since I'm finding, now this would be a negative 3h squared, so you can see it will do this. So it does make sense that we're doing a max with this one. So make dv over dh equals 0, right? So this is going to be 0 equals 36 minus 3h squared. 3h squared equals 36. H squared equals 12. H equals plus or minus root 12. The height has to be positive, so H equals root 12, which equals 4 times 3, so 2 root 3. Now this one didn't even ask for maximum volume. It says find the exact dimensions of the cylinder with maximum volume. So then I could just go and put this in to my formula, because I know H now. I know how H and R are related. I know that R squared equals 9 minus H squared over 4. So R is going to equal the square root of 9 minus 2 root 3 squared over 4. This equals the square root of 9 minus 4 times 3 is 12 over 4. 12 over 4 is 3, so this is 9 minus 3 is root 6. R equals root 6. So the max volume occurs when H equals 2 root 3, I guess that would be meters, right? Yep. And R equals root 6 meters. So you actually can see a big chunk of these is actually doing the algebra and stuff. Hopefully the new stuff you're getting. That's the getting it to one variable, getting this, so yep. Okay, what would you say R is 1/2 H? Why? No, even R is not, what? What are you asking again? Oh, you're saying in this case, oh. Okay, let's write that down. So, okay, we got h is root 12, r is root 6. So r is, or sorry, h over r would be root 12 over root 6. H over r would equal root 2. I'd probably test 2 or 3 before I made that assumption. Yeah, so I'd test a couple. It makes sense. Definitely makes sense, right? Because they, right, a sphere has that always built in. So that, yeah. If I was to guess, I would say for sure it should, but I'd test it. I wouldn't actually just assume that for a test, because that's how I usually get in trouble. Okay, we got, yeah. Basically, if we do it in the notes, it's fair after, not fair before. But we got a 1.5 meter fence high, stands on level ground, and runs parallel to a tall building. If the fence is 4 meters from the foot of the building, find the shortest ladder. So we're looking for a minimum, right? That will extend from the ground over the fence to the wall. So we have scenarios that are like this, like that, right? That obviously it's got to touch the ground, it's got to touch the wall, but what would be the shortest ladder that would make it? Okay, so we see here right angle, triangle. Should we go for Pythagoras? Similar triangles, okay. Which ones? The big, huge triangle, like this one and this one? Because, man, would I have a lot of unknowns there. Yeah. So this one, if you did this, see, the way that I thought about this one, okay, so say we know that this angle should equal this angle, correct? If the ladder changed and I went like this, you see how this angle would equal this angle, right? So I will get similar triangles no matter how I set up that ladder. And we know, so if we just looked at these two triangles, okay, now I know that this, for this triangle, this is 4 meters, right? So this side right here will be in ratio to this side. This will be in ratio to this, and this will be in ratio to this. Okay? So if I called this x and this y, then I have And there's so many ways you can do this ratio as long as you are doing the same thing over, like if you're doing x over 1.5, make sure you're doing 4 over y. You can do x over 4 equals 1.5 over y. Okay, now why don't I do just this triangle is y over 4. So if I went side to base, I'm going to go side to base on my small triangle. Now, what do I want to, that's the other thing too, is what do I want to keep the minimum? This big hypotenuse, right? So I want to minimize this hypotenuse, right? So which formula can I minimize on hypotenuse? Pythagoras. So if we call that, we could call it L if we want for ladder, to keep that straight. So L squared should equal 4 plus x squared (1.5 plus y). So maybe this is where we should have went first, because I want to, we've always done that consistently. What do we want to minimize? We want to minimize the ladder, in this case the hypotenuse. Then we want to get rid of either x or y. Yep. That's Pythagoras. So we got this side equals this side squared plus this side squared. So hypotenuse squared equals base squared times altitude squared. Okay, so it doesn't matter. I chose to actually get rid of my x value, but either way, you're still going to get the right answer. But if you bring the 4 up here, trade actually just bring the x up, bring both those up, you'll get xy equals 6. And then x equals 6 over y. Okay, now you can see already that's not going to be fun because we have a variable in the bottom, but you can do this to make your life a little easier when you get to the chain rule, because then you don't have to do the quotient rule in the chain rule. Okay, so let's get rid of that x now. So this is going into here. So L squared equals 4 plus 6y to the negative 1 squared plus 1.5 plus y squared. Okay, I have to do the derivative. Anything I can do to make this derivative nicer? No, I'm not seeing anything. So let's do it. I wouldn't do square root. That would make my life harder, right? Well, because then I've got to do the chain rule one more time. I got a 1/2. I'm going to have to bring that down to the negative 1/2. Okay. So this would be 2L dl over dy. equals 2 times 4 plus 6y to the negative 1. Chain rule, right? So that will be times negative 6y to the negative 2 plus 2 times 1.5 plus y times 1, if I did the chain rule. Okay, get rid of the 2's. Anything else? I might just try to get this all together. So I got L dl over dy. That's going to be 4 times negative 6. Okay, hold on. Oh yeah. Okay, so that's negative 24 y to the negative 2 minus 36 y to the negative 3 plus 1.5 plus y. Okay, now I'm going to find the max. So max, I'm going to make dl over dy equals 0. So then I'll have 0 equals negative 24y to the negative 2 minus 36y to the negative 3 plus 1.5 plus y. I just got to find y. You take y to the negative 3 out, but when anything equals 0, there's always a really nice thing you can do. Okay? Like if I, but I'm going to rewrite this as negative 24 for y squared minus 36 over y cubed plus, I'm going to change this to a fraction, 3 over 2 plus y. And this is over 1. When it equals 0, you have a nice convenience, and that is multiply everything by a common denominator, and you can get rid of all denominators. So you want to multiply, in this case, my common denominator would be 2y cubed. So you'd multiply this by 2y cubed, this by 2y cubed, this by 2y cubed, actually this by 2y cubed, and this 2y cubed. You're still going to get 0 over there. Okay, so that's going to give me 2 times negative 24. That's negative 48y. This is going to be minus 2 times, that's negative 72, and the y cubes will just cancel. That is squared, just cancel the 1. This one is, the 2's will cancel. So I'll get plus 3y cubed. And this one, I'm not canceling anything, 2y to the 4. Okay. Now this seems kind of still pretty out there, but if you just put a set of brackets around here, set of brackets around here, do some grouping. Can I take anything out of the first group? Okay, I'm going to take on a negative 24. That would leave me with y, 2y plus 3. out of the second set. Take out a y cubed. That would leave me with 3 plus 2y. Okay, and 2y plus 3, 3 plus 2y is the same thing. Since they both share that, pause there. I'm going to take that out. 2y plus 3, I'm going to take out, leaving me with negative 24 plus y cubed, or y cubed minus 24, same thing. Just nice to have the variable first. Now I can solve them as two different things. I can say, well, 2y plus 3 has to equal 0, and or y cubed minus 24 has to equal 0. So you're going to minus 3 and divide by 2. Y should equal negative 3 over 2. Okay, that's not a possibility because it can't have a negative. This one, y cubed equals 24. Y is the cube root of 24. Okay, which this one actually adds to 2 decimal places, but we can, so that gives us 2.88. But, and I can even simplify this more, right? There's an 8 in there, but I'm going to leave it right now because it actually only asks for the hypotenuse, and I don't have the hypotenuse yet. Okay, so how am I supposed to find x? Okay, because x is 6 over y. So x equals 6 over cube root 24. And that's 2.08. So now all I have to do is find z. Z is the square root of 6 over cube root 24 plus 4. Oh, that's supposed to be my, I used z in mine, but we used L for ladder. Okay, plus cube root 24 plus 1.5 squared. When you put that all in, you get 7.50 meters. So the smallest ladder, or the shortest ladder, equals 7.50 meters.